Hey guys, welcome to your 8.2 notes on multiplying and factoring. By the end of the day, you'll be able to multiply a monomial by a polynomial, and also to factor a monomial out of a polynomial. So let's jump right in with a review of the distributive property, and I'm so sorry, but I have spoiled everything. But that's okay, we'll move on. So when you multiply polynomials together, you're just going to use the distributive property. So it's like if we've got this number A and we want to multiply it by these things, these quantities, these variables inside here, we're going to do A times B plus A times C plus A times D. So we're going to distribute all of those guys. We're going to distribute A into all of those guys. So what that'll end up looking like is we're just going to take, the correct tool for the job. And we're going to make some space here and here. We're going to say, okay, well, A times B plus C plus D is the same thing as A times B plus A times C plus A times D. See how we distributed it to everybody? Oh, that's so kind of us. Nice sharing. So for example, here, negative x cubed is going to be distributed into each one of these guys. So what I'm going to do is I'm going to rewrite the polynomial with some space in between. So we've got 9x to the fourth minus 2x cubed plus 7. Okay? And now we're going to multiply negative x cubed times all of those guys. Boom, boom. So we're multiplying negative x cubed times 9x to the fourth. Negative x cubed times negative, times negative 2x cubed, and finally negative x cubed times 7. So let's simplify these guys up here. Okay, so first, to simplify this expression right here, I'm going to take all these guys together as one idea. And first I'm going to look at my coefficients. I've got a negative and a 9, so that'll be negative 9. And then I'm going to look at my x terms together. I've got two x guys, and since I'm multiplying them together, I will add the exponents. So 3 plus 4 is 7. Let's move on to our next term. Here we've got a negative times a negative. Negative times a negative gives us a positive. And then we've got one number to go out front. That's a 2. So we've got positive 2. And then our x terms, we have x cubed times x cubed. Well, 3 plus 3 is 6. So that gives us 2x to the 6th power. And then our final term here, we've got negative x cubed times 7, which is the same thing as negative 7 times x cubed. And that's it. We're done. We've found our product. So when we multiply x cubed times 9x to the fourth minus 2x cubed plus 7, we get negative 9x to the 7th plus 2x to the 6th minus 7x cubed. Things to look out for. Watch out for negatives. Watch out for exponents. And remember to distribute to everybody. So we're going to take these 3 reminders and we're going to use them to find this product. Let's take our 5n and distribute him to each of these guys. So again, just to help me write it out, I'm going to rewrite the whole polynomial again. 3n cubed minus n squared plus 8. If it helps to take this negative and scoot him forward, that's fine too. But everyone gets distributed not a minus 5n, a 5n. So this plus needs to go over here. Okay, let's simplify it up. 5 times 3 is 15. This is like an n to the first power, so that gives us n to the 4th power, minus 5n cubed plus 5 times 8 is 40n. Yay. So we have to be careful with our negatives. That negative n squared still has that negative down, that whole system. We added our exponents together when we multiplied, and everybody got a 5n. Sweet. So we did multiplication. Now we're going to undo multiplication to factor. So factoring just means like undo multiplication. You're going to break it up into its factors. Okay? So when factoring polynomials, we're still going to use the distributive property, but we're going to use the distributive property backwards using division. So you'll remember that a factor is what numbers multiply to get a certain number. So factors of 12 are numbers that evenly go into 12, like 1 and 12 and 2 and 6 and 3 and 4. So if we were to list out all the factors of 12, they would be 1, 2, 3, 4, 6, and 12. So that's all the factors. If we wanted to list the prime factors, that's when we can't break it up anymore. So some of you may have seen factor trees before. I can say, oh, 12, that's 3 times 4. Cool. 3 we can't split up anymore, so we stop there. 4 is 2 times 2. 2 we can't split up. 2 we can't split up. So 12 is 2 times 2 times 3. We can't split that guy up anymore. So this is a list of all the factors of 12. These are the prime factors of 12 because you can't break them up anymore. So when we factor polynomials, we're looking for their prime factors, factors we can't split up anymore. And in order to do that, we find their greatest common factor. Find their greatest common factor. Woohoo! And instead of writing out like a, I'm just going to do some examples. And then we'll call it. Okay, sweet. So to find the factored form, we need to break out the GCF. What do these guys all have in common? Well, let's look at the numbers first. 4, 24, and 8 all have a GCF of 4. And then x to the 5th, x cubed, and x, the smallest x they have, this is like x to the first power, right? They all have just one x. Go Christmas. Okay. They all just have one x in common. So our GCF here, well, we'll just say this way. Our GCF is 4x. So we're going to undistribute a 4x from each of these guys. Now, as I rewrite this, I'm going to tell you a cute story. I just found out that one of my dearest friends from college. One of my dearest friends from college is married, and I just found that out, so I'm very excited about it. You should ask me about him in class. You guys, such good stories. Okay, so what we're going to do is we're going to factor out this GCF. So we're going to divide each of the terms, 1, 2, 3, divide each of them by our GCF. Now in our first term, the 4 and the 4 are going to cancel out. Here, 24 cancels out with 4 to give us a 6, and 8 will cancel out with 4 to give us a 2. You know what, guys? Actually, I want to keep this on there. So now I'm going to rewrite this with all the work on it. There you go. Okay, sweet. All right, so again, the 4s will cancel out. Done. 24 cancels out with 4 to get 6. 8 reduces with 4 to give us 2. And then on the x side, here this is all like x to the first at the bottom, right? Cool. So let's work backwards. The x's, those will cancel out. 3 minus 1 is 2, so that'll be an x squared. And 5 minus 1 is 4, so that'll be an x to the 4th power. In case that's tricky to figure out, let me quick show you why 4x to the 5th and 4x reduce. Well, the 4's cancel out. Okay, awesome. X to the 5th is 1, 2, 3, 4, 5 x's. And then 1x on the bottom is going to reduce out with 1x on top, leaving us with x to the 4th. Nope, x does not equal 4. This is x to the 4th power. So that's why x to the 5th over x reduces to, these cancel out, x to the 4th. So that's fun. Okay, awesome. So let's clean it up without all the stuff that's been scratched out. We start out with x to the 4th minus 6x squared plus 2. Now we did factor out our 4x, so we're going to move him out to the front up here like that. So we undid the distributive property by drawing out a 4x from each of the terms. So we've got 4x times each of these guys. Now if we went through, and I'm not going to for time, but if we went through and distributed this 4x, we would get where we started. We would get 4x to the 5th minus 24x cubed plus 8x. So that's fun. Yep, so there it is. There it is in factored form. This will end up being our final answer. Yay! Okay, so we're undoing the distributive property. No, we're not going to use the distributive property. We're going to undo with the distributive property. Okay, so let's find our GCF on this guy. What do they have in common? Well, when I look at my numbers, 16 and 28, the biggest number that they have in common, oh, it's 4 again. That's lame. Okay, it will not always be 4, but it just happened to be 4. Okay, the biggest amount of A's they have is 2 of them. And the biggest amount of B's they have is 1 of them. So our GCF here is 4a squared b. So we're going to take each of these terms and divide it by 4a squared b. So 16a squared b to the 7th plus 28 a to the 4th b divided by, this time I'm going to keep the color coding on each of them, and you'll watch how they reduce. So let's divide. Awesome. 6 and the 4 will reduce out, nope, not 6 and 4, 16 and 4. Reduce out to 4. 28 and 4 reduce out to 7. A squared and a squared reduce out by a to the 4th and a squared reduce out to a squared. And finally, b to the 7th over b is b to the 6th, and b over b is not. So our final factored form is, this isn't even my final form, 4b to the 6th plus 7a squared. But remember to also include what we factored out. It can go in front. I like to put it in front, but you don't have to. But we factored out a 4a squared b. Ta-da! And that's it. To factor, find out what they have in common, and then just keep going until they don't have anything in common, and that's it. So you're undoing the distributive property. By the way, a quick note before we leave. What if we didn't notice something in here? What if we said we didn't notice they were both divisible by 4, and we just did 2 instead? What if we had factored out a 2? And not even the variables? We can say, hey, you know what? This is equal to 2 times, and I'm going to factor out a 2, 8a squared b to the 7th plus 14a to the 4th b. That's okay. You just notice, oh, hey, look, these are still divisible by 2. So I'm going to divide them by 2 again. So now we have 2 times 2 times 4a squared b to the 7th plus 7a to the 4th b, right? And then you notice, oh, shooties magooties, they've got variables involved too. So we're going to take out a squared b and a squared b from both of these terms, giving us 2 times 2 times a squared b times 4b to the 6th plus 7a squared. You multiply all these guys together, 4a squared b times 4b to the 6th plus 7a squared is messy, but it is the same thing as this guy right here, 4b to the 6th plus 7a squared times 4a squared b. Sweet. So you can go multiple steps, and that's fine. It's up to you. You can tiptoe through the problem, or you can take some leaps, and that's great as well. Yep. All right. There you go. Just distribute. Either do the distributive or undo the distributive property, and have a great time on your homework.